kind of wanted a little more time, so I'll give you guys till tomorrow night to get those Project Part B responses merged in with everybody else's. Yeah.
Can you show us like where the master file is? Because I searched in the project section, I couldn't find it.
So go to Canvas. And this is the evening class. So if you go down to so it says Project Math 40, Part 1, link to class master file down here. And that will bring you to it. So it looks like a bunch of people have put stuff in so far. Well, not a bunch. Some people have put stuff in so far. So what you'll do is go right down to the very bottom. All right, don't overwrite anybody else's. Go right in here and paste it in there. Everybody see that?
Yes.
Megan, you guys got that? Okay, good. All right. So let's get back to this stuff over here. You have some Connect Maths due coming up. This may actually, I might wait another couple days on that one. We might need to move exam 1. I'll know better after next class. If we need to do that, kind of depending on how far we get through, how much material we get through next class. So we might be looking at moving exam 1 out to the next class. Like right now it's scheduled for next Thursday. So it might be a little bit further than that. All right. Sample space. Noe, go ahead and read.
A sample space is the set of all possible outcomes of a probability experiment.
Right. So remember, if you roll a die, instead of all possible outcomes, 1, 2, 3, 4, 5, 6. Right. That's the idea of a sample space. It's a set of all possible outcomes. Here's my die. When you roll of an experiment. So this is problem number 1. Should look something like that. Yes. Couple things I'm going to be picky about. These have to be, you should start from the middle and from a spot. Don't have just the H and the T sitting out there. Start from here, branch out. From each of these should be another branch, starting from right there and going out. What's the probability of getting exactly 2 tails? So here's my sample space. You guys drew out your sample space over here. What's the probability of getting exactly 2 tails? Let's see, 2 tails. Well, that's this one, that one, and that one. So it looks like 3 out of 8. Yes? What's the probability of getting no tails at all? So which ones are no tails? What's no tails mean? All heads. So this is all heads. What's the probability of getting no tails? 1 out of 8. What about at least 1 tail? Either I have no siblings or I have, it's your line. Either I have no siblings or I have siblings, which means how many? 1 or more. Do you guys see what I'm saying? Either I have $0 in my pocket or I have 1 or more dollars in my pocket, right? Those are what we call complements. So either I have 1 or more dollars or I've got nothing, right? All right. So at least 1 tail means how many tails? 1 or more. 1 or 2 or 3 in this case, right? Because there's 3 possibilities. So it's all of these guys have 1 or more tail. What's the probability? 7/8. Are those last 2 related? Yes. How are they related? They're complements, exactly. Right? Because you're either in the red group or the blue group. You have to be in one of the 2 groups. Everybody see those? Right? The red group and the blue group. If you add those two groups together, you get everything. They're complements. You have to be one or the other.
So
Yeah.
for at least one tails where it says 7 out of 8,
Mm-hmm.
would it have to be like just one tails for it to be like 3 out of 8?
No, at least.
Well, right, but because like I at first put 3 out of 8 because I thought I was talking about.
Because you're
just-
talking about exactly one tail. We'd call that exactly.
Okay.
Yeah. When it says at least means I'm taking at least 2 classes. That means does that mean I'm taking 2 classes? No, it means I'm taking at least 2. I have 2 or more. You know what I'm saying? You have to be at least this tall to ride this ride. Does that mean you have to be exactly that tall to ride that ride? No, it means you can be taller too, right? Yeah. Are those related? Yeah. Oh, sorry. Comment? Or question?
Yes, can you elaborate on whether they're related or not? Is it, like,
What would you say on whether what?
can you elaborate on whether they're related? What
Yeah.
makes them be related? I didn't
They're-
understand.
So the red group and the blue group are what we call complements of each other. So, I mean, I guess you could say, well, they're not related because they have nothing in common. But what we mean is like, is there something that kind of connects, do they have some sort of relationship? Like rain or no rain has a relationship in the fact that they make up the sample space. You have to be one or the other. Heads and tails have a relationship because, in the sense that they're both the 2 possibilities of heads, flipping a coin. Right? So these are the 2 possibilities of having 3 children. Either you can have of having 3 coins flipped. You can either have no tails or you have 1 or more. So, yeah, I'm not going to ask you in the exam, what's the relationship? I'm not going to ask you that. But I want you to recognize the fact that these 2 things are complements of each other. Because complements will come up over and over and over again. Yeah. So it's, I do want you guys to get the idea of no tails is a complement of at least 1 tail. No siblings is a complement of at least 1 sibling. Right? Okay. We had no days that rained last month, or we had at least 1 day that rained last month. It has to be one or the other. Okay. So yes, they're complements. Ivana, go ahead.
An event with a specific outcome instead of outcomes. An event could be getting 10 out of 10 and only getting 2 points. Another event would be getting 2 4s and rolling 2 dice.
Probability of an event occurring when all events are equally likely. Remember, not all events are equally likely. Right? I tried it for the 49ers. I either make the team or don't make the team. Those are not equally likely events. I do not have a 50% chance of making the 49ers. So only when events are equally likely. And I like to just use a shortcut way and just call it number of successes over number of outcomes. So just reviews of last class. Here's our quiz problem number 2. All these puppies are equally likely to get picked. Let's probably pick a yellow lab or a chocolate lab. Are they mutually exclusive? Do they have anything in common? Can you be a yellow lab and a chocolate lab at the same time? No, so then they're mutually exclusive. That's what we call mutually exclusive. You guys remember that was the last thing we covered last class? So mutually exclusive, nothing in common. So you can just add their probabilities. So this would be 6 plus 8 over 20, 14 over 20. How about the probability you randomly pick a female puppy or a black puppy? So female, we have 8 of those. We have 6 black labs. But here's the thing. Are they mutually exclusive?
No.
No, you can be both.
Yeah.
So we have to subtract 3 because that's the overlap. These 3 black female labs are getting counted in the female total and getting counted in the black total. So they're getting double counted, bless you. So to subtract out one of them because it's getting double counted. So 8 plus 6 minus 3 over 20. Or you could have done it this other way. You could have just added up these, all the females and the black ones. Those, you could have just done it that way too and said, oh, 3 plus 3 plus 2 plus 3, right? You get the same thing. Doesn't matter which way you do it. You guys see what I'm saying, what I'm talking about? Those are the four, those blue light circled ones are the groups that are either female or black. You can just add those up. And you get the same thing. You get 11 out of 20 either way. How about the probability to randomly pick a male given it's yellow? You guys remember given? Yes? No?
Yeah.
Given means that you know, I'm giving you information. You know it's yellow. So you don't care about the other dogs. You only care about the yellow labs. How many yellow labs are there?
6.
6. You only care about the yellow labs? What's the probability that it's male? 4 out of 6. Good? Okay. Anybody need 30 seconds to talk to your neighbors about this? No? Okay. Moving on. This is in your homework. The reason why it's in your homework, the reason why we're doing it in class is because I like the problem, but I hate the fact that they didn't frickin' draw lines. Right? So this looks a little bit confusing, maybe. I think it's a lot clearer if you just do this. And then you put in your totals. 4, 10, 18, 32, 6, and 26. Then this looks exactly like our puppy's problem, right? This is almost the same exact thing as our puppy problem. So pediatricians, someone's a pediatrician, that means their area is pediatrics. So what's probably probability someone's a pediatrician? How many pediatricians are there? 10 out of 32. Out of means divide by, right? 10 out of 32. 10 over 32. Why don't you guys take 30 seconds with your neighbors and get the other one, orthopedist or MD. And check with your neighbors because I'm going to randomly call on somebody in about 15 seconds.
No, the company is still she did it, but she now she's saying yeah, how did it? Oh. So she did her she did the key plus the 2 and then the other 4 which was 32. So for the bottom line is
Rob, do you have it?
I think so.
Okay, what'd you get?
29 out of 32.
Oh, Rob. Okay, that works too. Okay, so how'd you find it?
The entire left column is MDs.
I'm sorry, what's that?
The entire left column is MDs, so the total there is 26.
Okay, so 26?
And then orthopedists, there are 3 that are unaccounted for.
Ah. Yep,
So we add that to our 26.
got it. So you did it this way. Took the 26 here, and they added in the 3 that were missing for the orthopedists. What's another way of doing it? You could also take in the total of your orthopedists, the 16, or sorry, the 18, add the 26, and subtract the overlap of 15. Either way, you get the exact same number, which is 29 out of 32. Good? You don't need to know both ways, just pick a way that works that you like and just stay with it. This matters, this is only useful really when you get into stuff where you don't have a table, then sometimes you need it. Okay,
Question,
yeah.
what's the purpose of the P parentheses pediatrician or P parentheses orthopedist?
Ah! So he's saying, what's this stand for? That's a great question. This means capital P, probability, parentheses means of. Probability of them being an orthopedist or an MD. Probability of them being, probability of pediatrician. It's going to come up a lot. Oh, and I said 3 sig figs. Okay, so 3 sig figs. 10 out of 32. 10 divided by 32. So this is equal to 0.3125. Sig figs means you start the first non-zero number and you count. 3 sig figs means 1, 2, 3, you stop there. I need to round to this spot. Does everyone understand what I'm saying? Okay, so I get to my first non-zero, after the decimals, first one's not 0. This is the first one as I'm going that's not 0, it's a 3. And then I count, I need 3 significant figures. So this is my first one, this is my second decimal place, that's my third decimal place. So 3 decimal places once you hit the first one that's not 0. 1, 2, 3. So I'm rounding to this spot here. If I'm rounding to this spot here, I have to look at the next one. If this is 5 or more, I round up. So let's take a look at this. Just in theory here, we have these two numbers. This is between 0.313 and 0.312. Everybody agree?
Yes.
So look, if this is 5 or more, I round up to 313. If this is less than 5, if it's a 4 or less, I round down to 0.312. That's what they mean by rounding down. They don't mean round down to 311. They mean this is less than 3125. So you'd round down to this. Yeah.
Do you ever do uncertainty?
No. If we do and it's called something else, then let me know. But yeah. I mean like Heisenberg's uncertainty principle or something crazy like that?
Well, more just like plus or minus, like 0.00.
Oh, yes, we will a little bit. We'll talk about margin of error a little bit, but not, yeah, not probably the way that you've seen in the past. It's a lot bigger than that, and it's margin of error. Yeah. Okay, so that's what they mean. 3 significant. So if you put this in, your homework will mark it wrong, just so you guys are aware. Which one does it want? This one or that one?
313.
Yeah, this one up here, because this is a 5 or more, you're going to round up. So you want this guy right here. Okay? While we're here, three significant digits means you go to the first non-zero one. 1, 2, 3. Look at that one. Do I round up or down? Down. So this would be, if I go 3 sig figs. Okay? All right. We'll get to it again later. We'll cover it again. Clayton B, go ahead and read.
The sum of the probabilities of all the outcomes in the sample space is 1 or 100%. You can't have a 50% chance of heads and a 25% chance of tails and a 0 chance of anything else.
Mm-hmm. We use that a lot. So if you add up all the probabilities of the sample space, you better get 1 or 100%. You can't have 50% chance of rain, 25% of cloudy, no rain, and 10% chance of everything else and not, send Sunny and leave like this extra 20%. It has to be kind of everything has to add up to 100%. Or look at it this way, I can't have 70% chance of rain, 20% of chance of no rain, right? Then that extra 10%, what would we do with that? The world blows up and it doesn't matter? I don't know exactly, but it's got to add up to 100%. I think you guys know that already. Who's problem 4 from your homework? So, what are the things we know about a pizza? There are a couple things we know about a pizza. What's the first thing we know about pizza from this place? It's either cheese or more than that, right? So it's either cheese or one or more toppings. That's one thing we know about it. What's the other thing we know about it? Yep. It's either eaten at work or it doesn't say. But so since it doesn't say, it's either eaten at work or what's the complement of eaten at work? Not eaten at work. Is everybody good with that part? So those are the two things we know about it. We should create ourselves a little table here. So it's either cheese or 1 plus toppings. That's either at work or not at work. Right, so those are the other options. Okay, so now you can fill it in. If you haven't drawn this, draw it now. What do we know? We know the 25 cheese pizzas were made, 19 with 1 or more. Are those at work, not at work, or the totals? The totals. Okay. And then we also know, something about some of this stuff. So fill in what you know, and then see if you guys can work it out. So we'll give you guys a minute to kind of sort through that.